Let's go, IC people! Woo!
Welcome back, everyone.
Welcome.
Everyone.
So today we've got a really special live stream for you today. We've got a guest co-host, Kyle from the Swap, the man himself, and he's going to be just joining us to chat with the great Houman Shadab from ICME about all of the incredible things they've got going on with zero knowledge proofs and the zero knowledge virtual machine. And of course, we've got Cedric from the founder of Code State. I'm Isaac, marketing lead at Code State, and yeah, let's kick things off. So yeah, I want to hand it off to Kyle. Dude, it's great to have you here. It's awesome seeing you at the conference, and it's great having you.
Yeah, no, I appreciate it. I'm also wearing the conference tee because
nice.
had to make sure I was representing while I was here. So I appreciate you guys having me. Looking forward to getting things going with the space here.
Awesome. And Houman, how have you been since the conference? Has everything been going well?
Yeah, I've been doing great, keeping busy with ICME, building and talking to folks out there in the market. So it's been exciting. Yeah, it seems like it was such a long time ago.
Awesome. Yeah, definitely. It's already starting to, time starts to fly. Cedric, where are you reaching out to us from?
Not at a train station this week. No bomb threats this week, but I did just land back in Switzerland, and I just hopped in a little booth here for the live stream, and yeah, really excited about reconnecting, Houman.
Wonderful.
Awesome. All right, Kyle, yeah, start us off. What's your first question for Houman?
Yeah, so Houman, real quick, we'll just start off with like some basic questions. So how did you end up into the ICP ecosystem, and what kind of like drew your interest with starting the project that you have?
Yeah, hi everyone, Houman Shadab here, co-founder of ICME. Yeah, I mean, I actually met Dominic and some of the early folks in the Dfinity ecosystem when it was very early on, 2016-17. So I learned about the project then, heard about its very ambitious goals, and kind of kept track of it that way.
Awesome. Yeah. And then you're working with, is it just Wyatt, or do you have a bigger team?
Yeah, we have some other folks as well, but definitely Wyatt is the technical founder of ICME, really leading the charge, being the master of everything that's going on in the zero knowledge proof area, all the good math and everything else.
Awesome. And as far as like zero knowledge goes, because I know we're going to have the video and stuff later on, but from my understanding of it, it's basically like having a third-party verifier to have like access to secrets, right? Or is there a better way of kind of explaining that for?
Yeah, that's one way to put it. I mean, there's the funny thing is about ZKP is like there's simple explanations, metaphors, analogies, where's Waldo, and then the math stuff. But yeah, it is a way for a verifier to mathematically prove, assure, if you will, that something is true based upon what a prover shows to them. So verifier and prover are always the two parties involved. You often hear about it in the privacy context. So it's a way to prove something or show something or state that you know something without revealing that thing, or at least without revealing anything extraneous or anything additional than the mere fact that something is true or you know it to be true. And this, when you get to the math, typically it involves it involves some kind of function, and that you know how to, for example, take a square root of something. And I can prove to you I know how to take a square root. I'm not going to tell you what the square root is. I'm not going to tell you what number I used to take a square root of. But you give me a number, I will take a square root of it, and the third-party computer proving system will prove that, verify that, and then we do that 1,000 times, and therefore I have to know how to take square roots of numbers. Otherwise, I'd just be guessing and be right every time.
Yeah, one of the simple metaphors that I like is showing that I know how to solve a Rubik's Cube, right? You mix the Rubik's Cube up, you give it to me, I put it under the table and solve it, and then I show you that I've solved it. And if we do this enough times, then it becomes more and more likely that I know how to always solve a Rubik's Cube within a certain time frame without showing you the exact algorithm of how I solve it.
Great.
Are there others that are very popular that you like or that like made it click for you?
I think that kind of example is very good. There's similar ones where people have two different balls in their hands. They put them behind their back, and they keep guessing the correct one because they can't see the color necessarily. So they keep showing the right one, but the person who's verifying does know the correct color because maybe the person on the ball is colorblind. I do think the Where's Waldo example is a good one as well, or even just simply, I can prove to you that I know the password because you can watch me log in a million times, but I'm not going to tell you what the password is. That type of thing. I think that works well too.
How does the Reverse Waldo one work?
Yeah, that's Scientific American ran a story about using that example, and the title was "Where's Waldo?" And I don't know who came up with the example, but I think it's been around for a few years. And the idea is I can prove to you that I know where Waldo is, but I'm not going to show you where he is. And the way you do that is you take the picture of all the people, you cover everything up except Waldo. And then I can show you, see, here's Waldo, but you don't see anything around him. You have no context for where he is on the map or on the picture. Okay. You can move around the picture all over the room, and every time you do it, I'll come back and find Waldo.
Would it also be considered a zero knowledge proof if I only just showed you, let's say, the quadrant that Waldo is in? So that get that right.
Yeah, I mean, if you're willing to buy it, yeah. I don't think that's exact enough, precise enough, though.
Yeah. Okay.
So talking about we talked about a little bit what they are, but why should people who aren't cryptographers really care? Why should they be interested, or what really makes you excited about it? I guess.
Yeah, I mean, I'm excited about it because it does touch upon, I think, a few really cool things in Web3 and generally. I mean, one is just the privacy idea that you can show that you're 18 or older, or that you're a resident of a country, or you have some some certification or credential, or you're otherwise verified or authenticated without revealing any private information. And I think in an era, as we're increasingly going towards obviously everything online and potentially being consumed by AI models, I think retaining privacy is a good thing, as well as things I think increasingly are trying to go on blockchain. Also, retaining privacy is a good thing as well. Coming from a legal and business background, there's lots of issues in the law and certainly in supply chain, of course, where you want to be sure something is true and not fake, and have real good assurance of that. And ZKPs are a good way to do that too. So that's not the privacy aspect of ZKPs. The other aspect is basically the verification aspect. And so I think that's sometimes underrated because it's taken for granted that a ZKP is quote unquote sound or complete. That's the kind of more formalistic words that phrases that people use. But if the math is good, then anything I can prove with a ZKP is in fact true, and vice versa. I cannot prove anything false with the particular algorithm or function or whatever you want to say. So I think that's a very good thing too, just proving things are true. And then scalability is the third big bucket that we see with rollups, of course. Where people are trying to scale Ethereum primarily, and with all these different essentially layer 2s, or maybe scale certain dApp chains. So that's cool too, because I do think to a large extent that the future of Web3 will involve ZKPs. Now, I don't think that Internet Computer Blockchain needs the scaling feature as much, at least, because it's quite fast already. But so apart from scaling, though, there might be privacy aspects that it could be helpful for. Maybe not, though. But certainly, verified computation, the verification stuff, I think, is important to everyone, including folks in the ICP, where you want to, and this goes into what they call ZKML, but you want to verify that the code is running correctly.
Okay. Yeah, I think of it as kind of like keeping all the benefits of the services you like without having to give away your right to privacy and autonomy. And so that's what personally I've always thought was interesting about it.
Yeah, but there's this integrity aspect of it too. It's like, as we're all increasingly relying on algorithms and trusting algorithms for a million different purposes, we become more dependent on them, and we want to just be sure. ZKP is one way to assure our proper reliance, that we can rely and trust algorithms.
And just quickly for my personal curiosity, how do you use CK to do scaling? There's a few layer 2s on Ethereum that CK Sync, or I think Starknet is one of them as well. What exactly do they do? Like, could you quickly go through like the general like mechanics of those and how they achieve scale as a layer 2 with zero
Yeah,
knowledge?
absolutely. Yeah, for legacy chains, if you will, like Ethereum, for slow ones, they're very slow by design or what have you. And the way to scale them is to not have every node verify or confirm the transactions, but basically do that off chain and have one computer do it and use a ZK proof to do it. So instead of a global state update, you're going to have an off-chain update and then a proof that the update was correct, and then throw it back on chain where you can verify the proof or store the proof there. So the idea is that you can batch together or group or quote roll up a bunch of these transactions and verify them off chain, because going back to the ZKP math a little bit, another kind of bedrock property of zero knowledge proofs is what's called succinctness. Succinct, namely that it's much easier, faster, cheaper, all that to verify a proof than to run it. So once you prove something off chain, you can verify it very quickly, including on chain.
Interesting. Okay. And do these rollups then have similar properties to the IC, where you can verify that a certain state existed, but you cannot necessarily get the state back?
I'm not 100% sure, to be honest. The rollups are typically themselves layer 2 chains that arguably do inherit the security properties.
Okay.
Yeah, there's different ways people are doing it. Polygon, we just talked to some of our friends there. They launched Polygon 2.0 last week, essentially. I think the entire system is based around ZKP, but also the entire system is a roll-up, a layer 2 primarily scaling solution. Now, interestingly, these scaling solutions are not necessarily ZK, to be honest. They're just scaling, but not necessarily, in other words, they're not necessarily private. So you have to include the ZK in addition to the snark or whatever it is, a ZK rollup. So you could just do a rollup, and that's great, but you have to do a ZK rollup to make it private. Just something to keep in mind.
I see. Okay. Interesting. Because I just came back from EFCC, and obviously I was talking about the IC with a lot of Ethereum folks, and the IC comes with a few paradigm shifts. Sometimes I feel it's almost easier for people in Web 2 to understand what the IC is and how it works. And I think one that's always a bit of a tough sell tough sale for me is that the IC doesn't retain all state, which we know it helps achieve its scale, and it's a feature. But I think it's something that's like inherently like hard to understand for ETH people.
Yeah. I think global state is, for a lot of blockchain folks, Bitcoin, I think as well, would think that is a necessary feature and a security property.
What made you like pivot from going from no code with ICP or ICME to using ZKPs?
Yeah, really where the market we think is right now, and where the demand is the strongest, in addition to our own kind of personal interest and passion for that area. We think I think ZKP is a really cool rabbit hole to go down and learn about. There's lots of different applications and use cases and research that's very difficult to understand, quite frankly, for me. But I think it's a really exciting area intellectually also.
Okay, and I imagine because your background of being a lawyer and stuff, this is something that would be very useful for more lawyers and other like big businesses and stuff to utilize your platform. Exactly.
Yeah, it really part of the reason my passion for ZKP comes from my background in law, business, enterprise type businesses, supply chain areas where authenticating and verifying things is very important. But also, there's a good article written by some legal academics and other computer science academics about what they call verification dilemmas in the law, where oftentimes you're forced to give up a lot of your privacy to prove something from a legal perspective. And they're saying ZKPs can really help not that for people to retain privacy in the first instance, but also just to more properly verify things. And I think we all know with AI and this next generation of media generation, it's going to be impossible to tell what's real and what's not without some kind of third-party verification system. And based on my research, ZKP does seem to be the best verification system. So if you compare, for example, how do I know this song is violating someone's copyright or not? You can use the methods that like Google uses, where everyone uploads their copyrighted context to a centralized database, and it checks against that, which it's just fine. If you upload copyrighted context to YouTube, it'll probably grab it. But if you kind of compare apples to apples a bit, it seems like ZKP is even a better method for intellectual property protection and all those types of things.
Yeah, that makes sense. And we're obviously like seeing a bunch of AI music and stuff created. I believe it was Grimes, artist. She said that like you can make AI music with my voice and stuff. I just want 50% of whatever like the income is off of it. So exactly. But yeah, it's interesting to see the shift with that, because there's other people that are I think at the conference specifically, it was Origin that mentioned that they were doing another proof before hitting blockchain with AI verification and stuff. So it's just interesting to see everyone kind of shifting towards verification before it goes to the chain.
Yeah, exactly. And there's a lot of let's say content creators, celebrities that are really upset about their content and their copyrighted media being used in AI. So ZK definitely has a use case in the ZKML category of, you prove to me your model detects and doesn't use copyrighted content. So so we can give it to you, or it's at least legal and compliant, whatever the case is.
So I'm trying to wrap my head around what you're building in more tangible terms. We talked in general terms, but like the no code version, you could log in, you can make a website, you can see how it all works. But now you're making this zero knowledge technology. So like, what is that going to look like when there's a service offering, like when it's complete, like how are you going to monetize, especially since you won't know who your clients are, right? Because zero knowledge. I'm just kidding. But yeah, like what's going to kind of look like in more concrete terms, as a business model? Yeah,
it's going to be, it could be API as a service.
Okay.
But right now we're also focusing primarily on, or at least initially on code licensing. So open source code where you can license, maybe more customized and highly more performant versions of it.
Okay. And so you're still going to be like engaged within the ICP community, or do you see like any big implications for the ICP network itself and maybe projects on the IC?
Yeah. I think just yesterday, Jans, if that's his name, was tweeting out about verifiable machine learning or verifiable AI. So that's very much something we're working on, maybe more generally. But we think ICP is really good for storing proofs, as well as potentially running proofs on chain.
Great. And
because if you run the proof privately, it's not as, let's say, as official as if you're saying, look, everyone, here's the proving system I'm using. And I use it to do this. And now everyone can see that. So that's public in that sense, because obviously proving systems themselves have to be verified and can have security flaws. And a few months ago, there was a security flaw found in one of the proving systems that's fairly popular.
Yeah. And like, how do you know someone's coded something the way that they tell you?
Yeah, and that's why you may have heard the phrase optimistic rollups for one of the Ethereum solutions. They're optimistic rollups because they basically assume they're correct until proven otherwise, to make it faster. So they assume that they properly validated an Ethereum transaction when they send it back, and then they do some kind of fraud proof or check afterwards, I believe.
Okay, that's interesting. And like, kind of from an entrepreneurship perspective, right? Like once the tech is complete, like what do you see as the greatest challenge for ICME past that point or moving
Yeah, I
forward?
mean, certainly there's such a wide variety of use cases. I think for a lot of kind of cutting edge products, finding those initial use cases and target segments that have the most need for this. And we've already had, I think, some pretty good conversations with lots of different companies as well as platforms and Web3 projects.
Okay, great. Yeah, and so we're getting close to the time where we need to start playing the recording here. Before we get into that, is there anything else you want to bring up or plug about the future? Any updates people should be looking out for? Or,
yeah, absolutely. Yeah, Wyatt's not here because he's coding. He's probably sleeping, but yeah, he's coding away, and we're going to be soon releasing the first implementation of Supernova. So Supernova is one of the most recent zero knowledge proof systems or methods. Let's say method that's very basically efficient and fast because it allows you to choose basically what little systems you want to use piece by piece instead of having these like massive proving systems just to prove like your age or something. Because historically, just for context, ZKP systems have been very expensive to run, very computationally intensive, to the point where there's specific hardware just for running ZK proofs. So it's similar in that sense to blockchain, like where some of it is very hardware intensive, but that's becoming less the case with like a lot of great research and development from academia that's coming straight to market. And so we're implementing the Supernova system. You can take a look at it. And that's one thing. In addition to we're doing ZK proofs that run in your browser. And that's a key differentiator for us. And what we're excited about. So ZK WASM, right? So WASM is this bytecode or this lower level code that runs in everyone's browsers. It's fast, it's secure, and universally adopted. And so having a proof running your browser and then like throwing them on chain, that's something we're looking to do and excited about.
Awesome. Great to hear that. And it's glad to see it. I mean, y'all have been working hard since Genesis. I remember just been seeing y'all around the ecosystem. So it's great to see that you're still pumping out great work. Yeah, and Cedric, Kyle, anything that you want to ask before we start getting into the recording?
Not a question, but I just wanted to say, I see we already get some pretty good comments. I just want to tell anyone watching, please leave questions. We're going to go through the talk together now, and then afterwards we'll bring up those questions to Houman. And yeah, just keep the questions coming. I see there's a lot of good ones already.
Great. All right, well, without further ado, let's watch the first the first recording of Houman's conference talk live on the internet, and then we'll come back and do the live Q&A.
We're going to welcome up Houman Shadab. He's to talk about the zero knowledge economy. The question he's going to be asking here is, will you be incorporating zero knowledge work into your application, and how? So please welcome Houman to the stage.
All right, thank you so much for the introduction. Thank you for the organizers for having me here. I've spoken at the International Monetary Fund, Consensus, that big conference, but this conference, in some ways, it's much more important and significant given the community aspect of it, and thank you for the organizers to putting it together. I think it's very important. This is how good work gets done and good people meet each other. So yeah, my name is Houman Shadab. I'm a co-founder of ICP, along with Wyatt Benno, who's out there somewhere. Oh, there he is. I can't see him, blinded by the lights, but we'll get more to that later. And so yeah, the title of my talk here is the zero knowledge economy, in reference to this idea of zero knowledge proofs, and this new wave of cryptography or encryption technology that's been around, of course, for decades. Like most cool things have been around for a while, but really starting to become more popular. Not yet mainstream, but that's what we're here to do, right? And that's what it's in reference to. And maybe one intuition behind this is that all of us have private thoughts, and we can speak to people without sharing our innermost thoughts. We can get dressed in the morning without necessarily knowing the process of that and knowing everything you're wearing right underneath. So there's this idea that there's this layer of things you don't share, and there's benefits to doing that. But when the digital world, in the current economy, in the digital economy, I think we're sort of oversharing, if you will. And that's what the zero knowledge economy is trying to prevent and improve upon. So just this sort of idea to float out there about the zero knowledge economy, a better way of doing things online, is that it's first completely integrated and completely private. So what does this mean exactly about completely integrated? What's an integrated economy? Well, it goes to the idea that that we hear a lot about is basically end-to-end transparency. Right? In supply chains, people say the ultimate goal is to know where everything is at any given point in time, any cargo vessel, any change in the weather that may affect the location of cargo vessels and so forth. If a butterfly flaps its wings in one part of the world and that affects the route of delivery or the pricing of something, that can be updated in real time and be connected. And so yes, that is a great, valuable thing. The more things are connected and transparent and public, and I don't think I need to tell this audience the benefits of making things transparent and public and real-time interconnected. And one way to do that, of course, is to put it on a network, a single network, or at least an interoperable network like a blockchain. And have you heard of the Internet Computer? Okay, it's a blockchain that probably is best suited for that purpose. And in terms of how does that happen? Well, there's value, okay, so economic value, business value, and that could be inherently digital. And so it's digital, perhaps tokenized. It could be digitized, so something that's physical has a digital representation, art, real estate, and so forth. And that's part of the tokenization idea that may go along with it and why blockchains may be well suited for that purpose as well. Okay, so that's the integrated economy. Who can be against something like that? And putting it on-chain, I think, is another part of this story, too, which is controversial, perhaps, in part because things that are on-chain may not be so private, may not be private at all. But what if we can have everything on-chain and everything encrypted or everything private as well? And that's the second component, perhaps, maybe the missing piece. So everything private, or the private side of this, the fully private economy, could include technologies. So I don't claim to be the biggest expert on all the new types of cryptography technology, related to cryptocurrencies, of course. But two of the major pillars I see out there, and there's certainly others, or maybe go by different names, are zero-knowledge proofs and fully homomorphic encryption. And the idea behind these zero-knowledge proofs that we've probably heard of before, chains like Zcash, privacy blockchains, use this idea of, and it goes back to academic research, I think even in the 80s, that I can prove to you that I know a secret is one way to say it, that something is true, that I possess something or knowledge of something without telling you anything else but that fact. It could be, again, the fact that I know a password. I know how to get into a door. And then I can prove to you just by walking through the door without giving you the key, without giving you the password. And what's interesting about zero-knowledge proofs, among other things, and that's kind of fun to go down the rabbit hole of ZKP, is that there are these really interesting schemes to essentially indirectly prove to you that I know this secret in order to keep that secret and just prove to you the consequence. And so in the literature, there's these really interesting conceptual puzzles and theories and analogies, like I've used so far, to say, here's what it looks like. And one of the main ones is the idea where there's a prover and a verifier. And I think Peggy, the prover, wants to prove that she can get through this door. And the verifier keeps asking her, well, if you go to one side, and you always come out the side A or B that I ask you to, if you do that 1 million times, you must be able to go through the door, because it would be too coincidental, right, for you to be able to come out the side I ask you to every single time without getting stuck and without just knowing what I'm going to say ahead of time, or without coincidentally going down the right path. But in the ZKP arena, as you can imagine, these proofs are not just kind of mind puzzles and stuff, which are good motivating examples and good ways to describe this, but they're actually mathematical proofs. and computationally intensive proofs, similar to how blockchain can be very computationally and resource intensive to do something over and over and over again to prove probabilistically, to be sure, but nonetheless with almost perfect certainty that you possess a secret, you know the password, you have the identity, you pass the check, you're in compliance, whatever the use case is, without showing me any other data. So that's kind of the cool part about it. And I think as a community, to talk about community, it's good for us to, I think, to learn these analogies, to be able to explain in as simple terms as possible, get accurate, to other audiences, what is this really all about, in addition to making blockchain maybe better, because a lot of these technologies are used, especially ZKP, to make blockchain faster and more scalable and more private. And the idea here is that the privacy angle is that you can have smart contracts that are don't reveal all the data about the transaction, or even as much as they do, which is not entirely transparent, to be sure. Fully homomorphic encryption, as a kind of another pillar of this, regardless of how we describe any particular technology, the idea is that you can run and work with and compute encrypted data. And so that's almost magical too, right? And that's obviously very technical, but the idea is that you can take data in encrypted form in a database, let's say, and run mathematics, run a function on it, and get your results. So the idea here is on the left, the cloud there is the processing, the function, the compute, and out pops the result, which can be unencrypted. And the idea is there is like now companies can work together and not have to worry about sharing data. And from a legal perspective, did I tell you all I'm a lawyer also? So watch out. Now, the idea is that you don't have to share data because there's massive, for example, privacy laws that must be complied with anytime you have personal data or confidential data from a contract's perspective and you receive it or share it with other parties. But if you never receive the raw data, the plain text, essentially the confidential, the legally triggering data in form that's legally triggering, you can still work with it. Perhaps another idea of fully homomorphic encryption is also your own database, right? One problem that cybersecurity tries to address is that people within a company stealing data, or people hacking into a company and stealing data within the company, not just data in the hands of third parties. So of course, if your own databases are encrypted every time you work with them, that could be another application too. But of course, FHE is quite costly and computationally intensive as well. Not the most efficient way to do things out of the gate, at least. And so what a private economy can do also is not just be made up of these pillars, but can combine them in really unique ways as well. So we can verify privately, for example, with ZKP, that your fully homomorphic encryption scheme is valid, and maybe the proofs can be public as well. And that's part of the blockchain angle, which can be, let's put these proofs on chain, or perhaps run the proofs or what they call circuits on-chain as well. So ZKP, if you're looking for a new area to come up to find interesting terms to use in everyday conversation, ZKP is a great one. You can say things like Halo and Plonky and be very, very serious about that. That was my attempt at humor. Okay, so why not share private data? Well, I think we all know the value of most of these things. Some of them are obvious, but we're in the knowledge economy, and even data like who are my customers, how do I do business, how do I price things, knowledge assets, if you will. We want to keep that private. Less obvious, I think, are cost and speed. Basically, the idea there is that if you can do something with sharing less data, it can be faster and can be cheaper. There's just less to process. I know you've done it. Thank you. I don't need to go through your entire database or see your entire process to know that you comply with something or your identity is valid from, let's say, a know your customer anti-money laundering perspective. At least a better automation, also better verification. So it's not just doing the same old thing privately, which by itself is a huge value, and itself is value enough for doing that, but it's also a better verification. So I can verify my age, I can verify my identity using ZKP, but in a private way, so I can tell you I'm an adult without telling my exact age, which is 32, by the way. But I can fake an ID, right? You can fake your age, you can fake and hack perhaps centrally controlled data more than decentralized ones, but ZKP provides better verification, or at least possibly, than standard, let's say, government-issued IDs, or name your ID system or what have you. And that leads to people are more willing to cooperate if they don't have to share as much information from a business perspective, perhaps, and other privacy-protecting purposes, and new business models, okay? If you're thinking about the profit perspective, the revenue generation, the new forms of cooperation, it's like, yeah, we can do business in ways we haven't done before. We can maybe come up with new business models entirely if we can interact much more privately and do it at scale as well. So just a few examples here. The supply chain context. Obviously, just to be clear, confidential data is, as you can imagine, as everything else becomes commoditized, your knowledge, your connections, your network, your audience is very important, your community. Why not share private data? Cybersecurity, hacking, that's all a very, very large industry. In some respects, maybe in many respects, maybe in all respects, the zero-knowledge economy, ZKP, FHE can make cybersecurity software obsolete because you're never sharing data. Data is always encrypted, even locally or in your cloud. And so there's nothing to steal. But theft happens probably more than you think, even in the business-to-business context. People, show up with fake badges to pick up cargo and steal it to job sites. And it's a huge international problem, in a sense, a type of maybe modern piracy, if you will. But again, having a more verifiable proof of your identity that can't be faked, but it's also kept kind of private, not just on blockchain, but maybe privately on blockchain or some kind of decentralized network, is helpful. Also, why not share private data, or why employ these new technologies is artificial intelligence really blurring the line between truth and falsity, fiction and reality. And is that a real image? Has the image, even a fictional image, has it been doctored, right? So forms of verification are really important, I think increasingly so. And just not sharing data, right? If I want to work with people but not have that data end up in an AI model, we want to share it privately. And that's where FHE would come in as well. So, if knowledge is power, perhaps zero knowledge is trust. I tried to think of something that rhymed with power. I just could not find the word. And in that sense, perhaps counterintuitively, or at least maybe more realistically, all I really care about is trust, maybe perhaps more than transparency. Like, I don't need to know everything about a business counterparty or some other person I'm dealing with, as long as I can trust that certain things are true about them, their identity, whatever characteristics, their compliance with law, and so forth. And so we can achieve trust, I think, more easily, which is going to still be difficult, but I think we can achieve more universal trust, and that's part of the project of blockchain, more easily than universal transparency over everything, and of course, that's not even desirable. And that's what we're doing at ICP. The idea is to take this technology, put it in a ZK WASM implementation, so it can run more scalably everywhere. You can ask Wyatt about that. And I will say thank you very much. See you at lunch.
All right.
What a way to lead to lunch. Yeah.
Houman, I liked your joke. I think it just caught people by surprise. They weren't expecting it. That's all.
I hear you. Well, there's plenty to come.
Yeah, there's a couple in there. I was joking in the private chat that you and David Albusco should do a bit at the next conference. That'll be fun.
Sounds like fun.
Do a little stand-up.
Yeah, it's a little healthy stand-up, right? Well, we had Jesse do a great intro with a lot of AI memes, and you know what? I should be doing that, Cedric. I'm going to put that on my list to bring up the AI memes of our speakers when we bring them out, because there's a couple cool ones of you, Houman. But yeah, no, great job. It's a good talk.
Wait, which character were you, Houman? Which one did he turn you into?
I thought I saw Thor and an animated version too. Professor.
Okay.
Some cat professor anime. I gotta find it.
Nice.
Those are great. And it's a lot more work than you would think to come up with those. AI doesn't give you a great result right off the bat. Not yet, at least.
Yeah.
Hey, so Kyle, you know what? As the guest co-host, I'm gonna put it up to you. Why don't you pick one of the questions from the audience to highlight here?
Okay, I'll go with the first one from Raul. So it said, "Good morning, fam. I have a general question, but would still like your answer. In your cosmovision, what is the potential impact of the zero knowledge economy on society?"
Yeah, my answer would be that it is just a society where you can protect your privacy more, where confidential and proprietary data and information of companies is also protected. So maybe there's more business being done because companies are not reluctant to do business because they know they would have to share things, as well as, in the legal context too, you could engage in a trial and prove things in trial without having to share potentially harmful or embarrassing things about yourself, or again, trade secrets about a company just to win a lawsuit. So I think it's in that sense a more private, a more secure economy is a zero knowledge economy.
Great. And you go ahead, Isaac.
Well, I was gonna say I would be nervous to live in a future where zero knowledge isn't prolific, because you don't need zero knowledge in a dictatorship. But if you have where personal freedoms are thriving, that's the kind of future that needs zero knowledge protecting people out there. So like I want to make sure I want to live in a society with zero knowledge then. So yeah, I love what you said there. In total agreement. All right, back to you, Kyle. That was a great question from Rule.
Yeah. And then so it looks like Manny. So let's talk about AI verification, brainstorm tech stack with ICP approach on terms of verification.
Yeah, my only contribution here would be to think that ICP is probably the only chain where you can run a lot of this on chain, a lot of the AI models themselves, and then maybe in parallel the verification of those models also. So I think that would be maybe my starting point to think about it. I know that I think ICP, the Definity Foundation, they're doing a new grant program around on-chain AI. And so that's something we're looking into, to be sure.
Awesome. Yeah, I saw that Definity launched like a $5 million grant pool for AI just the other day. And then real quick to touch on, Manny had like a follow-up to using ICP. He's like, do you like see any securities flaws or like an example of like spread the word, I guess?
Yeah, if you look up, I think if you search for Nova, N-O-V-A, security flaw, it'll come up. Nova is one of the more advanced ZK proving systems. And I think it was a few months ago, a flaw was detected, but it was already, I think by the time it was detected, it was already fixed. But I think the broader point is it goes to show you that obviously the proving systems themselves need to be checked and properly created, and so that's why there's a large academic community surrounding this, and that's really where this stuff came from, academia.
All right, here's one more by Encriptados TV. What are the advantages and disadvantages of implementing ZK proofs in terms of computational efficiency and security? So I guess where this question is going, I think security is separate, but in terms of computational efficiency, like how hard is it to compute these proofs and prove that they're correct compared to how much you're saving?
Yeah, the general answer, the historical answer is that computing a zero knowledge proof has been very computationally intensive. So it was a non-starter to do them on chain. And also they required a lot of specialized hardware. Over time, even to do off chain, over time, everything has become cheaper and faster and less resource intensive. So it really depends on the size of the proof and the system you're using, but it can take a few seconds up to an hour to do proofs that people are still kind of using in practice.
Okay. Yeah.
Great, great. And I really like this question from Marcella. Could you provide examples or concrete use cases where zero knowledge tech has been seamlessly adopted? So like, is there anywhere in industry where it's kind of like currently being used right now, or is it still kind of on the fringes?
Yeah, still on the fringes in the industry, but it is being used in a real way in Web3 for roll-ups or scaling.
That's true. Yeah, I mean, hey, there are people making livelihoods and money off of these roll-ups and everything going on right now. So
yeah, companies like I know we've been talking to companies like Nokia. They want to use our ZKML code when it comes out. So lots of more traditional companies are really starting to look at it as well. And I suspect, especially next year, we're going to see lots of announcements. In the Zcash days, when Zcash was new, I think Coca-Cola and ING, they were trying systems. I think they were mostly prototypes. And I think just because of the last year or two of new developments in ZK, it's become much more accessible. And at ICP, we are trying to make it the most accessible with ZK Wasm and running in browsers and the other technology like Supernova and other stuff that my co-founder is really working on hard to implement. And so for the next step for ICP, we'll be seeing the launch of that by September.
great. And now you basically, I'm just gonna show it, but you basically already answered this question by Paul there. So thanks for that.
Yeah, and then I see this one from Emmanuel. You pretty much touched on it a bit for the progress that's been made in recent years, but he's also asking what like promising applications do you see emerging in the future, like outside of ICP?
Yeah, I mean, there's just so many. Really, it's interesting to see what will be adopted. But there's things like verifiable voting. I think people have used to some extent to vote and show that you voted, but of course not say who you voted for. There's such a wide potential range of applications in both Web3 and Web2. I think we're going to see it in gaming also. Anytime there's things that are potentially very intensive computationally, you can offload onto faster systems and to bring it back, but also to say, hey, is this media fake or real, AI generated and fake, or is it real? I think there's going to be a real need for it there.
That's probably one that's going to be pretty impactful, yeah. And that one that will have a pretty big impact on our real life quite soon. Angel had a question here as well. Where do you recommend to investigate more about ZKP? So where would you send people that want to learn more about implementations of zero knowledge proofs and how to use them, maybe in their own applications as well?
Yeah, definitely. There's lots of good open source code repos out there for developers from various people and systems. We think we're going to be releasing the most exciting code. But to read about it, check out the ZK newsletter. There's a few updates that come out a lot. The ZK Zero Knowledge podcast is a good place also. Go through their archives. And yeah, generally, lots of good people are writing about this topic from various perspectives, simple to very complex. So just a couple of days ago, another new, I think, very nice introduction and overview of the topic came out recently too. So there's lots of, I think, increasing attention on this topic. And like I said, I think just early July, Scientific American had a nice overview of it as well.
Great. And I think we have time for one last question here. And I'm not sure I entirely understand it, but I'll read this one by Bertrand. So does this mean that everyone at ICP should have their own private principle and state that it cannot be stolen or used by a bad actor? I think they might be referring to just the need for privacy on the IC, which, I'm curious to get your opinion on the new feature that they're working on to address that with like a vet key. I was in the community call they had recently. Like, what are your thoughts on vet key and like privacy on the IC now?
Yeah, no, I think it's needed and very helpful, and an awesome new infrastructure piece that is getting implemented on the IC, as well as I believe on-chain encryption is coming. And so, yeah, I think those are all complementary. These like new wave of what people call PETs, privacy enhancing technologies. And I think ICP really, as a blockchain, is leading the charge in many ways to do things on chain, and I think it's just continuing in that process. So yeah, the vet keys I think is very good and really protecting on-chain data from node providers, and then things should be pretty good to go from there. Yeah, that's awesome. Well, for everyone out there, if you need more information, visit icme.io, and they're also on Twitter. So make sure to go ahead and follow Houman. And thanks for joining us, everybody. I have a few quick items. So for our ambassadors, the Zeely keyword is hanging with Houman. I thought that was a fun one. I came up with that one, proud of it. So hanging with Houman. So fit that in there and get your reward. As a reminder, our conference talks are every Thursday at 8 a.m. PST, 5 p.m. CET, and our next one is actually someone who wasn't a speaker at the conference. It was Ray from Catalyze. So we're going to have him on as a special guest. We had a gap in our agenda with some speakers shifting around. We had invited Ray to come be a speaker, and he wasn't able to make it due to some personal reasons, and we missed him at the conference, right? But he's a great community member, so we're really excited to have him on as a guest. And the only other thing here is just a quick reminder to join our ICP groups on WhatsApp. We have some great discussions every week, and we have a lot more coming out. So I'm going to leave this up here. And I wanted to really thank you so much, Kyle. Really appreciate you joining us. It's just been great connecting with you more this year, seeing you at the conference. You do a lot for the ecosystem, so I really appreciate you making the time and just enjoying this time with Houman with us. And of course, Houman, thank you so much for everything. I really appreciate it. You've got an incredibly impressive background. I was looking at your LinkedIn before this. Most people might not know you had testified to Congress before. You've been in all kinds of publications. The ecosystem is honored to have you. So thank you for all that you're doing to further. The honor is all mine, and the pleasure, of course, to you. Thanks for having me, everyone. Hope to see you in person soon, hopefully in Paris, but any place is fine, actually. All right, everyone. Thanks for joining the live stream. Stay out there.
Before we forget, Isaac, we're on YouTube. We got to remind people, please subscribe, like, notify for the next ones. Every week we're going to go live. This really helps the algorithm. If this talk brought any value to you, please don't forget to like and subscribe. Now back to you.
Yeah, no, that was a good one. That's the one I missed. But yeah, everyone, please like and subscribe. Thanks for joining so much. Fight the FUD and stay bullish. We'll see you later. Take care.